All right, so this lesson is all about congruent figures, and we're going to focus on congruent triangles. Whenever we have a congruent set of triangles or any figure, we're going to use this congruent symbol right here, which we've been using so far, but this symbol does mean congruent. And if we want to remember what congruent means, it means that all the parts of the shape are equal in size and the shape didn't change. So these two triangles, even though they are oriented differently, they have all their features are the same. They're the exact same size and they're the exact same triangle, just with a different orientation. So when I look at this part right here is called a congruence statement. And a congruence statement is really important because it helps me figure out which part of the triangles go together. I can't just do that by eye. I need to specifically follow this congruence statement. So what this tells me is that angle R, or point R, corresponds to point L. So this R and this L correspond to each other. So those two angles are congruent. That's one thing that we know. Angle R is congruent to angle L. Now, then I see the second one, right? It says that S corresponds to N. So I know that angle S and angle N are congruent. And then last but not least, I also see that T corresponds to E, and so that tells me that angle T is congruent to angle E. So anytime I have a congruent statement, the order that it's written in is really important, and it tells us specifically what is congruent to what. Now, I also have not just 3 sets of congruent angles, but I also have 3 sets of congruent sides. And an easy way to figure out what sides are congruent can be to do what I just did, which is label the angles. So I know the side that connects my purple and my orange is congruent to this side that makes my purple, that connects my purple and my orange. Or another way to think about it, R to S is congruent to L to N. So I can pull it straight from that, that statement. So segment RS is congruent to segment LN. I also know that segment ST is congruent to segment NE. And then last but not least, I know that segment RT is congruent to segment LE. And like I said, I can pull this from the diagram from looking at my color labels, or I can take this congruent statement, RST is congruent to triangle LNE, and I can go in order. RS to LN, ST to NE, and then also we have R to T and L to E, right? So I can do it for either by following the order of my congruent statement or by the color coding that I did. So that's how I know these parts are congruent. Now, all the parts of a congruent triangle are congruent. So there's actually a phrase that you might see, congruent parts of congruent triangles must be congruent. And so sometimes we abbreviate that with CPCTC. All right, so I want you to take a second and pause the video and name all 6 corresponding parts. So which sides are congruent and which angles are congruent. Okay, now let's give this a look. So if you wanted to, you could have drawn it out, or you could use our congruent statement. So I can get the angles really easily. Angle R is congruent to angle G. Angle S is congruent to angle H. And angle T is congruent to angle K, right? All I did was go in order. The first one is congruent to the first one, the second one to the second, and so on. Now, for the segments, I can still go in order. I just have to go one step at a time. So segment RS must be congruent to segment GH. Pay really close attention to your notation here, right? Segments are congruent, whereas the lengths of segments might be equal. Then I also have ST and HK. So segment ST is congruent to segment HK. And then last but not least, R to T. So segment RT is congruent to segment G to K. So, like I said, I want to come back to that distinction for a quick second. If the segments are congruent, it does mean they're the same length. So this statement, segment RT is congruent to segment GK, is true. And it does mean that the length of RT is equal to the length of GK. Notice when I'm talking about length, remember how I don't put any symbol above? That's what tells me I'm talking about length. So lengths are numbers and they can be equal. But segments are figures. So we talk about those as being congruent. So there is a difference there. All right, now what can we do with congruent figures? So we have given doormat, basically, right? We have triangle DOR and triangle MAT are congruent. And we're given all this information. Before I do anything, I need to go ahead and draw a triangle. And I like to draw all my triangles nice and Sesame Street-like because I like to give myself a lot of space to fill things in. And I want to label that, even though I know that that might not be how they look, right? But I do need to make sure I label them accordingly. DOR is corresponding to MAT. So it's really important that I label them in the same order, in the same way. And then I can go ahead and label my angle measures. So this is 5x plus 3. The measure of angle O is 8x minus 2. And the measure of angle A is 6x plus 16. So when I go ahead and look at these triangles, right, we know that angle O and angle A are corresponding angles, and corresponding parts of congruent triangles are congruent, okay? Oh, and I just realized I may have written this wrong. This should say corresponding parts, not congruent parts. Corresponding parts, right? The parts that correspond to each other are congruent. Sorry about that. So we do know that these two parts correspond and the triangles are congruent. So that tells me that they are equal. And if they are equal, I can set them up equal to each other and I can solve. So I get 2x equals 18, which means x equals 9. Now, the question actually asks me to classify by sides and angles. So in order to do this, I'm going to need to figure out what my angle measures are. So I'm going to go ahead and substitute in. So if I substitute in to measure of angle D, if I substitute 9, I get 48 degrees. If I substitute into angle O, I'm going to get 70 degrees. And if I substitute, oh, I don't have an angle T or R to substitute, but I could find the measure of angle R by subtracting 180 minus 48 minus 70, because we know that all angles, the interior angles of a triangle, sum to 180. So if I subtract these, that tells me that my angle R is 62 degrees. So when I look at this, because all my angle measures are different, right? None of them are the same. That tells me that none of my side lengths are the same length either. So that means it's a scalene triangle, right? No congruent sides. And if I look at all of these angles, all three of these angles are acute angles, and none of them are congruent again. So that means this triangle is an acute triangle because all three angles are acute. So that is a scalene acute triangle. Both triangles are congruent, so they look the same. They're the same size, the same shape, and they're both going to be scalene acute triangles. All right, now let's look at another example problem. Okay, again, the first thing that we want to do is we want to make sure that we are drawing this triangle set. And when I draw this triangle set, I want to make sure that I label them accordingly, right? I don't want to label them in a different way. So I made them look the same as best as I could. If I label this triangle ABC from bottom left around clockwise, then I need to do the same with DEF. So I need to make sure A corresponds to D, B corresponds to E, C corresponds to F. Now, it tells me that the side length AB is 4x minus 1, and the side length BC is 3x minus 2, and the side length DE is 8x minus 13. So when I take a look at this, I see that I have two sides that are corresponding to each other, and we know corresponding parts of congruent triangles are going to be congruent. So these two corresponding parts must be equal to each other. So I can set up that equation and solve. So that gives me 12 equals 4x. So x must equal 3. Now, the question actually asks me to find EF. I don't have an expression for EF, but I do know that EF corresponds to BC, so that means those two parts are equal. So if I want to find EF, I can find the length of BC, and that will also be the length for EF. So EF must be 9 minus 2, so that's 7. And there's our answer. All right. Now, last but not least, we are going to look at a systems example. So how do I know this is a systems example? I see both x's and y's, right? So I'm going to have to set up two equations. Now, before I set up any equations, I need to go ahead and draw these triangles. So I do have triangle far and then triangle out. So I am going to go ahead and draw them both and label them both. And remember, when I'm labeling them, I'm not doing this in a way which is haphazard, right? I want to make sure that F corresponds to O, A corresponds to U, R corresponds to T. They have to be in the same position so that we can make sure that we know which angles are corresponding and congruent and which sides are corresponding and congruent. So then I am going to go ahead and label this. So it says FA is 2x plus 5y. It says AR is x plus y. OU is 14. And OT is 8. And then it also gives me some angles. It tells me the measure of angle T is 10x. It tells me that the measure of angle F is 3x minus 2y. And it tells me that the measure of angle A is 20. So our job is to find UT and classify. So I need to find X and Y first. So I need to identify which parts of my triangle are corresponding. So I know FA and OU correspond, which means they are equal. So I can set up one equation that says 2x plus 5y equals 14. Now, I'm struggling here because I don't see any other sets of information that we have to set up an equality, right? Angle R and angle T are corresponding, but I only have one expression for that. Angle U and angle A are corresponding. Angle F and angle O, but none of them have like a matching set, right? But if I know that angle T corresponds to angle R, that means angle R must also equal 10x. And what I see now is 3 angles that make a triangle. Any interior angles that make a triangle, they must sum to be 180 degrees. So I actually can set up a different type of an equation. I can say that 20 plus 3x minus 2y plus 10x has to equal 180 because this angle corresponds with R, right? And so all 3 angles have to sum to 180. So I'm going to go ahead and combine my like terms. So that gives me 13x minus 2y equals, I'm going to subtract that 20 to the other side. So equals 160. And so now I have a nice system of equations, right? I have that first equation, 2x plus 5y equals 14. And that second equation, 13x minus 2y equals 160. So why do I need a set of equations? Well, in order to solve for x and y, I need to be able to eliminate a variable. Now, unfortunately, when I'm looking at this, there's no easy combination here, right? I can either get these to both equal 26, like one positive, one negative, or I could make these both equal 10, one positive, one negative. It doesn't really matter which one I pick, right? So let's go ahead and just say that for ease, let's say that I went ahead with this one. I could multiply this top equation by negative 13. And I could multiply this bottom equation by positive 2. So that way I'm going to get a negative 26x and a positive 26x. So it will eliminate. That was my goal, right? So that's going to go ahead and give me, let's see, 2 times negative 13 is negative 26x. 5 times negative 13 is negative 65y. And 14 times negative 13 is negative 182. And then my bottom equation, 13 times 2 is 26x. Negative 2y times 2 is negative 4y. And 160 times 2 is 320. So here's my system. I had to adjust both equations, which was a bummer. But no big deal because now I have negative 69y equals 320 minus 182. Let's see, what is that? That's 138. And if I divide both sides by negative 69, now I find out that y must be equal to negative 2. Now, once I know what y is, I want to go find out what x is. So I think I'm going to use this original equation because it's the most simple. And I'm going to find out x. So 2x plus 5 times my y of negative 2 equals 14. And so that gives me 2x minus 10 equals 14. So 2x equals 24. So x is equal to 12. So now I finally know what is x, what is y. And what I can do from here is I can find UT and I can classify. That's what I have to do next. So first of all, which side is UT congruent to? UT and AR are corresponding sides, so they have to be congruent. So I can find UT by substituting into this equation for AR, which is x plus y. So my x is 12 and my y is -2. So UT must be 10. So if UT is 10, I'm going to go put it up here, and OU is 14, and OT is 8, I have no congruent sides, right? So that means that the triangle must be scaling. Okay, so the triangle is scaling. That's classifying it by sides. In order to classify it by angles, I'm going to need to find what the angle measures are. So I already know one of these angles is 20 degrees. So that's an acute angle. I need to substitute in for angle F and angle R to find out if those angles are also acute. So I'm going to substitute into angle F. So 3 times 12 minus 2 times -2. And I see that the measure of angle F, let's see, what do I get? 3 times 12 minus 2 times -2, I get 40 degrees. Okay, so that's also acute. And then last but not least, let's check angle R. The measure of angle R is going to be 10 times x, which is 12. So that's 120 degrees. That's an obtuse angle. So that means this triangle is an obtuse triangle. So our triangle is scaling and obtuse. All right, that is all for today. Hopefully, if you have any questions, you'll reach out. And I hope you have a great rest of your day.